This video will show you the key details about the computer science and statistics majors and help you decide which would be best for you. According to pay scale, the average salary of someone with a bachelor's degree in computer science is $85,000. This makes computer science one of the best paying degrees currently available. Many of the alternative degrees to computer science will also have high average salaries. However, not only is computer science one of the best paying degrees, but it also puts you in a good position with just a bachelor's degree. On the other hand, many of the alternatives will require a master's degree to be competitive when seeking a job. Also, many people that get alternative degrees to computer science actually end up finding themselves in computer science type roles. For example, it's not uncommon for math and statistics majors to find themselves working as software engineers after graduating. There are many different types of jobs that a computer science degree can open you up to. They can include software engineer, database administrator, data scientist, machine learning engineer, app developer, and a web developer. Many computer science majors end up getting jobs as a software engineer, which is one of the highest rated jobs currently available, with strong predicted job growth. Typically, you will find that the core required classes in a computer science degree will be enough to qualify you for most entry-level software engineering jobs. Data science and machine learning are also becoming popular among computer science majors. A computer science degree can be enough to qualify you for these jobs. However, it will usually be necessary for you to choose your electives carefully or to self-study things from data science and machine learning in order to qualify for them. If you want to get a job in data science or machine learning, it would help to take classes in data science and machine learning if they're available at your university, to learn Python programming, and to complete data science or machine learning projects. A computer science degree combined with classes relevant to data science and machine learning should put you in a good position upon graduating. If your university does not offer classes in data science or machine learning, it would help to self-study them using websites such as Coursera, edX, FreeCodeCamp, which now has a data science section, and Udemy. Since data science and machine learning are rapidly evolving, you should expect to have to self-study them a lot regardless. Generally, a computer science major is considered as being one of the easier STEM majors, and most people would agree that it is slightly easier than a statistics major, which will normally be a lot more math heavy. With that being said, the major will still require a lot of work at times, especially once you are done with your freshman year. In a computer science major, some computer science classes you can expect to take can include Introduction to Programming, Data Structures and Algorithms, Assembly Language, Databases, Computer Architecture, and Computer Networks. You can also expect to take some mathematics classes, including linear algebra, discrete math, and calculus. You can also expect to have the choice to take classes from fields such as machine learning, artificial intelligence, computer graphics, and computer networks. Before you start the major, it would be very important to consider what you think you would like to do with the degree. This is so that you will be able to optimize your classes according to what you hope to achieve with it. For example, if your goal is to get into machine learning or data science type roles, it would help to take calculus and linear algebra sooner, since they will likely be a prerequisite for the machine learning and data science classes. Many students quit the major because they find it is a lot more theoretical than they were expecting. Another important thing to consider is that computer science is not purely focused on programming. Instead, computer science focuses on things such as how to write computer code optimally, so that computer programs can run efficiently and at scale. I have another video on my channel talking about whether or not a computer science degree specifically is worth it, and how you can make the most of the major. The Bureau of Labor Statistics predicts that the demand for mathematicians and statisticians will rise by 33% by 2029 compared to 2019. This is mainly due to the surge in data that companies have been receiving in recent years, and that they need people with mathematical and statistical skills to make sense of. According to PayScale, the average pay of someone with a degree in statistics is $70,000. This is higher than the average pay for most majors. However, competing majors such as computer science and the different engineering degrees have significantly higher pay. For example, the reported pay for someone with a bachelor's degree in electrical engineering is $92,000. And as mentioned earlier, the average pay for someone with a degree in computer science is $85,000. The reason why statistics has a lower average pay could be that data analyst type job roles are very popular among statistics majors. According to PayScale, these roles only pay $60,000 on average, whereas roles such as software engineer have an average pay of $90,000. Since statistics is used in many different fields, a statistics degree should open you up to many different job opportunities. According to PayScale, the most common reported jobs people with a statistics degree report having are data analyst, data scientist, actuarial analyst, software engineer, financial analyst, and a business analyst. However, because it is a general degree, if you get a statistics degree without taking more applied classes, it can be difficult to compete for more specialized positions that tend to be more desirable. If you do end up choosing a statistics major, this means that you should take courses from the field that you want to enter, do summer internships, and to complete projects related to that field as well in order to be competitive when seeking a job. It also means that alternative majors such as computer science or the different engineering degrees are likely to give you an easier time when looking for a job after graduating. This is also shown in the data, since computer science and engineering both report having higher average pay than statistics. Many statistics majors go into software engineering after graduation. If you want to qualify for software engineering jobs, it would help to make sure to take a data structures and algorithms class, since the material from that class gets tested heavily in software engineering interviews. It would also help to complete some software engineering projects, such as a web app, so that you have a portfolio that you can show to recruiters when looking for software engineering jobs. Data science is also becoming a very popular career path among statistics majors. To qualify for data science jobs, it would help to make sure to learn Python programming, data analysis using the Pandas library, machine learning, and to complete data science projects as an undergrad, and to try to get some data science internships. If you combine a statistics degree with software engineering skills and classes related to machine learning and data science, it would put you in a very good position upon graduation, since software engineering, data science, and machine learning engineering jobs are all very well paid with strong predicted job growth over the next decade. If you get a statistics degree by itself, it would still put you in a good position to be competitive for analyst-type job roles, but they do not pay nearly as well as data science, software engineering, or machine learning engineering job roles. The statistics classes in a statistics degree can involve a lot of mathematics. As a result, you can expect to take a number of math classes in your freshman and sophomore years. These classes can include single and multivariable calculus, linear algebra, and discrete math. After finishing the math prerequisites, you can expect to take a number of different statistics classes, including Introduction to Probability and Statistics, Mathematical Statistics, Regression Analysis, Statistical Learning, and Time Series Forecasting. Depending on the university, you can also expect to have the option to take classes related to data analysis, machine learning, and data science. Something to consider is that different statistics programs will focus more on certain areas. Some programs will be more theoretical and focus more on traditional statistics classes, whereas others will be more applied and have more practical classes, such as data science, machine learning, and Python data analysis classes. If you are not yet in university, it would help to consider the type of job that you think you would be most interested in, and to apply to universities that offer classes related to that type of job. If you are already in university, it would help to choose the most applied classes to what you are interested in, and to supplement it with self-teaching in areas where there are not classes related to what you are looking for. For example, if your university does not offer classes related to data analysis using Python and the Pandas library, it would help to learn it on your own time, using websites such as edX, Coursera, Udemy, or more specialized data sites like DataCamp and DataQuest. Statistics is generally considered as being a moderately difficult major. Most people would agree that it is harder than a computer science major, but easier than a math major. Some of the more advanced classes can be proof-based, which tend to be much harder than the more computational classes, but you might not have to take many of those, depending on your specific statistics program. I have another video on my channel talking about whether or not a statistics degree specifically is worth it and how to make the most of it. The key advantage that a computer science degree has over a statistics degree is that it is a very employable degree by itself. This is because the degree will qualify you for software engineering roles, which are very popular right now and well paid, whereas a statistics degree needs to be combined with something more applied to make it as employable as a computer science degree. In addition, a computer science degree is generally considered as an easier degree than statistics. This means that you'll have more spare time as a computer science major to focus on things such as applying for internships, jobs, doing research and completing projects to help improve your resume. Also, most computer science degrees will require many math classes, including linear algebra, discrete math and calculus. These classes are usually enough for most mathematical job roles, including data science and machine learning, in terms of the math that is required. Also, if you're interested in machine learning specifically, for most people a computer science degree would be the better option. This is because most machine learning classes will be taught within the computer science department and will often count as core classes in the major. Also, computer science will generally prepare you better for graduate school for machine learning, which is also often taught as part of a computer science master's degree. However, a statistics major can also be a very good major. Even though it is not as employable as a computer science degree by itself, it is still a very employable degree, and you can expect to qualify for a lot of analyst-type job roles with it. To qualify for the more specialized and high-paid roles, it would help to make sure to take classes related to them. When combined with computer science, machine learning and data science classes, and self-teaching, a degree in statistics would be a very employable degree. If you do decide to major in statistics, I would strongly recommend that you at least minor in computer science, and make sure to at least take a class in data structures and algorithms. Doing so will help you immensely when applying to jobs. Also, it would help to make sure that you learn programming and complete projects related to the field that you want to enter.